Alright, David Harry here. So, which of these two Macs is going to be the fastest at exporting video from DaVinci Resolve? Is it going to be the 3-year-old M1 Max MacBook Pro with its 10 CPU cores, 32 GPU cores, and its 32 gigabytes of RAM? It's also got 1 terabyte of storage. Or is it going to be the brand new M4 Pro Mac Mini with its 14 CPU cores, 20 GPU cores, 48 gigabytes of RAM, and it has also got a 1 terabyte storage. Anyway, what I'm going to do here is dive straight into this testing. Now, there will be chapters to take you through this stuff, but what I will do is come back at the end for a summary, because let's just say that these results were a little bit surprising for me, and I really do need to talk about them at the end of the video. Okay, so the first test is going to be done on the M4 Pro Mac Mini. And as we can see here, there's some of the basic information for this Mac. However, the most important thing for this particular test is probably to make a note of the operating system, which is macOS Sequoia 15.1. Now, that is the most up-to-date version of this particular operating system on the day that I am doing this test, which is Wednesday, the 13th of November. Now, what is important is that I am going to be using the exact same version of macOS when I flip over onto the M1 Max. So what I'm going to do here now is to just get into DaVinci Resolve. Let me just quickly show you the version of DaVinci Resolve that I am using, and that is DaVinci Resolve Studio, and the version is 19.1 build 12. Once again, this is the most up-to-date version of Resolve Studio on the day that I am doing this test, and again I will use the exact same version when I flip over onto the M1 Max. Let me just go full screen here. So what I'm going to do here is to just quickly run through the parameters for the media, and then I will just go through onto the sequence parameters. So as far as the media is concerned, this is Apple ProRes 422HQ, 59.94 frames per second, 3840 by 2160 as far as the resolution is concerned, which is 4K UHD. Now, as far as the actual settings for the project are concerned, as we can see here, once again, it is 4K UHD and the timeline frame rate is 59.94 frames per second. So what we have got here is a project with media that matches its frame rate and also its resolution. So what I'm going to do here is just flip over onto the exporter. Now, once in the exporter, I'm just going to show you some of the basic export settings here, and once again I will be doing the exact same settings for the exporting from the M1 Max. Now, as far as the audio is concerned, this is just on 320 kilobits per second using the AAC codec. However, the audio won't really have any bearing on anything here to do with speed. Now, as far as the video codec is concerned, I am using H.265. It is within the QuickTime wrapper. Then, as we can see here, the resolution is matching the resolution of the media and the project, which is 4K UHD, and also the frame rate is identical, which is 59.94. Now, as far as quality is concerned, which is the bit rate, I've set this to automatic because this is just a basic test for timing, like the export. Now, of course, if I were to use a low bit rate, it's going to be worse quality than using a high bit rate. However, this is not a quality test, and also, just to be clear, it doesn't matter what we set the bit rate to, it will not affect anything to do with the timing of the export. So to be clear, even if we use a very low bit rate or a very high bit rate, the export will be exactly the same as far as the time taken is concerned. And then down here, as we can see, I am using main 10, and I do not have optimize for speed switched on, so that is switched off, and basically main 10 means that I am exporting to 10-bit 420. Now, just a very quick thing I want to make a note of here. Usually I would be using multipass encode. However, I can't right now with H.265 in main 10, because if I do, unfortunately, the file that will be generated will be corrupted. And the problem with that is something to do with the very latest version of Sequoia matched with the very latest version of DaVinci Resolve Studio. However, even if I were to do a 2-pass encode or a multi-pass, the actual speed that it takes is identical. So pass 1 and pass 2 are both the same anyway, so it wouldn't really make any difference anyway as far as seeing the speed that the encode is at. It would just take twice as long. Okay, now what I've done up here, as we can see, is to give this a file name which I've called M4 Pro, and then what I've done here is to export this to an external SSD. So as we can see, that is my external Western Digital 4TB Thunderbolt 4 SSD, which is formatted to APFS. And actually on that point as well, let me just make something else clear here before I go any further. If I have a look down here, I think, where are we? Hold on. Oh, there we are. Inside here is where the media is as well. So the media for the timeline is actually on the internal drive for the Mac, and that will be the same when I go to the M1 Max. So to be clear, the media being used is internal on the Mac, and where I'm exporting to is external to the Mac. Okay, now to be honest, that isn't actually necessary for this type of test, because the reading and the exporting of the media would all well fit with inside the bandwidth for using it on the internal drive. However, I'm just doing it this way because a couple of people have asked about that on previous tests. Why did I not export to an external drive? So I'm just doing it because people asked for it, and also it will be identical when I go and do the next thing. Okay, so here we go. There is the actual file there in the render queue. So I'm just going to tap on render all. Now this is just going to go off. It's actually going to do this quite quickly because it's only like, you know, a 1-minute clip here. But as we'll be able to see up here, this is the actual speed of the export. So it's hovering around 52 frames per second. So to be clear, what's going on here is that this number is indicating how many frames per second is being encoded. Now it just happens to look like 60 frames per second, which is what the media is really, 59.94. However, that just happens to be like, you know, that's just pure luck that it's looking like that. This number that we're looking at up there, it is just purely how many frames per second are being encoded, and it's irrelevant of the actual frame rate of the media. Now I was going to speed through this, but I don't need to now because I'm nearly at the end of it. So we will get a timing here. So if we just give this a few more seconds, there we go, and there we go. As we can see, that took 59 seconds. This is all a little bit, obviously, a bit odd because I'm using a timeline which is 1 minute long. I'm also using 60 frames per second effectively, and it just so happened that the encoding was almost 60 frames per second and the time taken was almost a minute. These are just happenstance here. This is not by design. Okay, so as we could see there, we could see the encoding frame rate was thereabouts 61 to 62 frames per second for the encoding, and the time taken was 59 seconds. So now let me flip over onto the M1 Max. Okay, so I am now over onto my M1 Max MacBook Pro, and as you can see here, there are some of the details about this particular Mac. However, the most important thing is to note the actual operating system here, which is macOS Sequoia 15.1. So obviously the same OS as I was using on the M4 Pro Mac Mini. Okay, so let me just bounce into DaVinci Resolve here, or DaVinci Resolve Studio. Now what I'm going to do first of all is just to show you the version that I'm using. So as you can see, it is DaVinci Resolve Studio 19, version 19.1, build 12. So the exact same version that I was using on the Mac Mini. Now as far as the media is concerned, it's all identical. So as we will see here in the file inspector, Apple ProRes 422HQ 59.94 frames per second, 3840 by 2160, which is 4K UHD. Also, this particular media is located, it's actually on the desktop, so it's obviously on the internal drive as well. And then if I just come to the settings, as we can see, it is 4K UHD basically, and also it is 59.94 frames per second. So everything is all matching up exactly the same as far as the media and the timeline and the project is concerned compared to what I've just done on the M4 Pro Mac Mini. Now if I just flip over onto let's see the exporter here, I'll just go full screen. We're going to see on the exporter everything is identical as well, so it is QuickTime H.265. Also, as we can see here, use hardware acceleration if available is switched on. Now this was obviously switched on the previous test on the Mac Mini, because of course what this video is about is specifically testing for the hardware acceleration, so it has to be switched on. Okay, now as far as like the resolution and the frame rate are concerned for the export, these are once again 4K UHD 59.94 frames per second, once again matching to the source media and the project as well. And then as far as quality is concerned, once again set to automatic, although it wouldn't make any difference. I've also got optimized for speed switched off, and then I'm using main 10, which is 10-bit 420, and multipass encode is switched off. Now I'm also exporting to an external SSD here, and this happens to be the exact same SSD that I exported to when using the Mac Mini, and I'm going to call this file M1 Max. So let me just pop that over here into the render queue. Now I'm just going to hit render all, and then the first thing we're going to do is have a quick look at that number up here, which is the amount of frames per second that are being encoded. So is this going to be much slower than the M4 Pro Mac Mini, or are we going to get a surprise? Let's see, I've just started, and yeah, we're getting a surprise. As you can see here, this is hovering around 100 frames per second. It's dropped to 99.5, 99, 99.5, 100.5. I think we're safe in just calling that 100 or maybe 99. There we go. We'll call it 99 or 100. It keeps bouncing between the two. And obviously with it being much faster, it's nearly done the export. Let's have a quick look here. Hold on. So we're coming up to the ends. Right, so I'm going to call that 99 frames per second. But as you can see here, look, it done that in 37 seconds. So that's 37 seconds compared to 59 seconds for the M4 Pro Mac Mini. Okay, so to an end summary then, and I don't know how long this is going to go on for, because I've actually got a lot of questions off the back of that test there. However, I think the first question that I want to ask you, the viewer, is, did you expect those results there? Because I most certainly did not. In all honesty, I thought that the M4 Pro here, regardless of what type of machine it was in, I thought that this M4 Pro SoC was definitely going to make mincemeat out of the M1 Max in basically anything that I would throw at it. And I most certainly expected a very simple, straightforward exercise in video transcoding or video encoding, whatever you want to call it. I actually thought that that was going to be something that the M4 Pro here was definitely going to be way better at. Now, let me just run through some stuff here, which is like basically what's really surprised me. So, as far as the M1 Max is concerned, we've got 10 CPU cores on that. Now, in this particular type of exercise where we're just doing transcoding essentially or encoding, those CPU cores don't really come into play here. So although the M4 Pro here is a lot more powerful as far as the CPU cores are concerned, like I say, for that particular type of exercise, they don't really come into play that much. And we are basically comparing, I think it's 8 performance and 2 efficiency on the M1 against, 10 performance and 4 efficiency on the M4. However, we have to remember that this is like 4th generation now, and with each generation, each of those CPU cores becomes more powerful. So on a per core basis, all the CPU cores in here are a lot more powerful than what they are in the M1 Max. Now, when we go over to the GPU cores, although the M1 Max here has got 32 of them and this only has 20, again, this year-on-year iteration, as it were, of the GPU cores has meant that although this only has 20, in all of the benchmarks that you'll see flying around, what they're basically suggesting is This is only a little bit slightly slower than the 32 cores on this because these are a lot more powerful on a per core basis. So basically what we should be saying is the GPUs are effectively the same. Now, those are the main two things that you would use when video editing. However, what we were doing here was doing a transcode or an encode exercise, in which case most of the work is going to be down to the encoder chips. Now, once again, everything on the M4 Max should be faster because it has been all updated, and the iterations over the last number of years all actually get better year on year. So the encoders themselves are supposed to be better as well. Now, actually, there is another thing to consider here, and that is memory bandwidth, for which the M1 Max, for as old as it is, actually has a higher memory bandwidth than what the M4 Pro has got here in the Mac Mini. However, and once again, due to the type of test that went on here, that really shouldn't play a part either. So for me personally, I'm kind of getting really confused here as to why this was a lot slower than this thing here. Now, we could also say, well, actually, the M1 Max has got more of the actual encoders built in. However, with that, my understanding is with DaVinci Resolve, it doesn't double up on the encoders for like a single export task. It only uses the one encoder. Now, I could be wrong on that. I mean, maybe that has changed over the years. Actually, on that point of doubling up on the encoders, whether that be through serialization or it's a parallel process, I don't know. I did read recently on the Blackmagic DaVinci forum where somebody had said that compressor, which is an Apple product, partway through its life cycle, it was updated to account for the extra processors which you will get on the Max chips. However, like I've just said, I'm not aware that Resolve does this. So once again, I'm really stuck as to why there's this huge difference. And it is a huge difference as well. You know, we went from, what was it, around what, 62 frames per second on here to like just under, or I'd say 99 frames per second on the M1 Max. Now that is actually a massive difference. Now you can sit there and go, well, okay, it was only the difference between 37 seconds to 59 seconds, which within itself isn't that much, but that was only a 1 minute clip in the timeline. If you were exporting something that was an hour, then you're definitely going to see a huge difference there. Now, proportionally, or by ratio, it's going to be exactly the same, but in real world time, it's going to feel like a lot longer because it will be. Now, one other thing that I just need to get into in a little bit of detail, but I will do this as quickly as possible, is what was going on in the timeline for both of those tests there. So basically, what I've just done was essentially used Resolve as a transcoder or an encoder, whatever way you want to look at that. Now, in order to do that properly, what we can't be doing is processing the video in the timeline, because that processing of the video in the timeline will slow the video down from reaching past the buffer into the encoder. So what we need to do with stuff like this is to throw that video as fast as possible off the timeline through its buffer and then into the encoder. Now, in this instance, that is exactly what we were doing, because there was nothing going on in the timeline to slow down the transfer of data through a buffer and then into the encoder. Now, at that point, what we were seeing was both of the encoders on both systems operating at their peak speed. And the reason why is because we were actually shoving that data to the encoders as fast as the encoders could possibly handle them. Now, there is another scenario that we could have done here, although it would not then have been testing the encoders. And in this other scenario, it would have worked out possibly that the M4 Pro might have been the winner. And that is, if we had, like, say, a lot of processing going on within the timeline, let's just say a lot of noise reduction, basically anything where the timeline would need rendering, as in the timeline won't play in real time anymore because there's too much being asked of the processing, so the timeline has to be rendered. Now, at that point, it's arguable that because the M4 Pro here has got, like, you know, stronger CPU powers, as it were, this will actually do more at that point compared to an M1 Max. So basically what we would be seeing is that the M4 Pro might maintain real time where the M1 Max might fall below real time. Now, at that point, what would happen is the M4 Pro here would be throwing the data into the encoder quicker than what the M1 Max could, because the M1 Max would be getting slowed down trying to like utilize its CPU processing to process stuff that's in the timeline before it can get to the buffer into the encoder, whereas the M4 Pro here might be able to do that stuff in real time as long as whatever the tasks are in the timeline are favoring the processing power of the M4 Pro here. Now, like I say, in that particular scenario, yes, we might have seen a difference, because what we would have been doing at that point is not necessarily taxing the encoders, but actually taxing the processing power of what was going on within the timeline before it went to the encoders. Anyways, I'm going to leave it at that, because anything from this point on will just simply be guesswork from my part. Now, there is one thing though that we can definitely categorically come away with from this video, and that is that the M1 Max does indeed encode faster than what the M4 Pro does. For whatever reasons, it just is faster than it. Now, if anybody out there knows why the results of this test have been the way that they have been, please do share that in the comment section below, because I, for one, would be really interested to know the answer to that one. Anywho, I'm David Harry. Thank you very much for watching this video. Take care and goodbye now.